So let's kind of go over a brief historical perspective of acids and bases. And we're going to focus on Bronsted-Lowry acids and bases. And the definition of acids and bases has evolved over time. In the 1880s, a chemist by the name of Arrhenius proposed the following. He said an acid is going to be a substance that, when dissolved in water, increases the concentration of H+ ions. And we can say that the concentration of H+ ions is going to be greater than the concentration of OH- ions. A base, on the other hand, is a substance that, when dissolved in water, increases the concentration of OH- ions. And we can say that the concentration of OH- ions is going to be greater than the concentration of H+ ions. Well, this definition worked great for aqueous solutions, okay? But the Arrhenius definition of acids and bases only defines acids and bases in aqueous solution. And we can have acids and bases in any state. So from this, we need to know a better definition or a better explanation must be proposed. And in 1923, Bronsted and Lowry gave a more general definition. And basically, they defined an acid to be a proton donor. And when we refer to a proton, we refer to an H+ ion. And a base is referred to as a proton acceptor. And again, the proton is the H+ ion. So if we look at a generic expression where we have HA in aqueous solution plus water in equilibrium with H3O plus in aqueous solution plus A minus in aqueous solution, if we look at the forward reaction, we can say that the HA donates its proton, or its H+, to the water. Okay? So the proton donor, HA, is the Bronsted-Lowry acid, and the proton acceptor, in this case water, is the Bronsted-Lowry base. If we look at the reverse reaction, we can say that H3O plus donates its proton to the A minus. And again, here we can say that the proton donor is the H3O plus, so it's going to be a Bronsted-Lowry acid. and the proton acceptor, which is the Bronsted-Lowry base, is going to be the A minus. So if we look at these, remember that an acid, a Bronsted-Lowry acid, which is a proton donor, are going to be these species right over here, the HA and the H3L plus. So we refer to these as the Bronsted-Lowry acid. And in terms of a base or a proton acceptor, in this case, we're going to look at the H2O liquid and the A minus. And this is going to be our Bronsted-Lowry base, or in this particular reaction, the proton acceptor. So this definition can be applied to more than just aqueous solutions, and it's more general, and it's kind of a definition that's stuck, and one that we'll use to describe various phenomena involving acids and bases. Okay? So from here, we can then come up with a term called conjugate pairs, or conjugate acid-base pairs, which we will talk about in the next video.